All right, so to find the first 5 terms, we're going to go ahead and we are going to So we're going to plug in 1. Oops, let me get back here. Okay. So 8 to the 1 is going to be 12 times 1 minus 2. So that's 12 times negative 1. That's negative 12. 8 to the 2 is going to be 12 times 1, 2 minus 2. So that's 12 times 0, which is 0. 8 to the 3 is going to be 12 times 3 minus 2, which is 12. So our pattern here is that we're adding 12. So that's going to be negative 12, 0, positive 12, 24, and 36. For example 2, my 8 to the 1, I'm going to plug in 1. Remember that we start with 1 unless it tells us otherwise. So anything to the power of 0 is not 0, it is 1. 8 to the 2 is going to be negative 4 to the 2 minus 1, which is negative 4 to the power of 1. 8 to the 3 is going to be negative 4 to the 3 minus 1, which is negative 4 squared, which is 16. So notice we're multiplying by negative 4. So 1, negative 4, 16, negative 64, and I think that's 120. Let's see. 64 times negative 4. 256. Sorry about that, guys. Number 3. All right, so this one they're giving us an A1, so we're going to fill that in as our previous term because AN minus 1 means previous term. So my first term is 1. My second term would be 2 over 1, which is 2. My third term would be 2 over 2, which is 1. So I'm at 1, 2, 1. My fourth term would be 2 over previous term, which is 1, 2 again. My fifth term, I guess, is going to be 1, 2 over 2. So 1, 2, 1, 2, 1, and then 2. Well, that's sixth term. All right, number 4, we're going to start with negative 10 as our previous term. So our second term would be negative 10 plus 10, which is 0. So our next term is going to be our negative previous term plus 10. Can't have a really negative 0, so that's 10. Our fourth term is going to be negative previous term plus 10, so that's going to be 0. Our fifth term is negative previous term plus 10. Obviously, it's going to be 10. So our pattern here is 0, 10, 0, 10, 0. All right, so expand each and evaluate. So this gives us an equation. We can't use the shortcuts. So this is our starting number. This is the number we're going to end by putting in. Then we're going to add them all together. So my first term is going to be negative 1 to the third power times 5 times 3. So negative 1 to the third power is negative 1 times 15 is negative 15. My A2 is going to be negative 1 to the power of 4 times 5 to the 4. So when I do that, that's going to be positive 1 times 20, which is 20. A3 is going to be negative 1 to the power of 5 times 5. Let me make that prettier. Times 5 times 5. So that's negative 25. And then my final one, there are 4 terms between K3 and K6, is negative 1 to the power of 6 times 5 times 6. So that's going to be 30. So in order to get this answer, we add all of these together. So we're going to add all those together and we get an answer of 10. Next one, number 6, the first number we're going to plug in is 6 and we're going to stop at 11. So we're going to do 12 times 6 minus 2, so that's 12 times 4, which is 48. 12 times 7 minus 2, so that's 12 times 5, which is 60. 12 times 8 minus 2, it's 12 times 6, which is, my brain fart right now, I should know that, 72. Okay, so the next thing's going to be 12 times 9 minus 2, which is 12 times 7. 12 times 7 is 84. Next one's going to be 12 times 10 minus 2, which is 12 times 8. 12 times 8 is 96. And the last guy's going to be 12 times 11 minus 2, which is 12 times 9, and 12 times 9 is 108. So our last step is to add all of these together. 48 plus 60 plus 72 plus 84 plus 96 plus 108. So in my calculator, I'm going to add all these together, which equals 468. Now if you notice, okay, if you look at the next one, we notice that those tricks can be used because we have a constant, a linear, and a quadratic. So the equation for this one is going to be n times c. Okay, so our number of terms, we're going to do 88 minus 11, which is 77 plus 1. So that's going to be 78 times 2.5. So 78 times 2.5 is 195. For this one, this is our linear. So because we have k as a constant, our formula here is n times n plus 1 over 2. So when I do that, my number of terms would be 99 times 99 plus 1 over 2. So in my calculator, 100 times 99 divided by 2 is 4950. Our last has the k squared, which makes it quadratic. So our cheat formula for this is n times n plus 1 times 2n plus 1 all over 6. My number of terms here would be 25. So 25 times 25 plus 1 times 2 times 25 plus 1 all over 6. And the answer here is 5525. All right, so is the sequence arithmetic? So we minus 144 here. We are not minusing 144 here. For the next one, we're minusing 10, minusing 10, minusing 10. So yes, my D would be negative 10. For the next one, yes, we are subtracting 0.9. Write an explicit and recursive formula. So what am I doing? What is my D? Well, I am going down 0.1. So a to the n equals my first term, which is 12 plus n minus 1 times my D. My recursive formula is my a to the n equals my previous term minus 0.1. So now we have to find the 20th term. So we're going to use the explicit formula for that. So 15th term is 12 plus 15 minus 1 times negative 0.1. So our 15th term would be 10.6. For our next one, our common difference is 1/5. So D equals 1/5. So our explicit formula, a to the n equals my first term plus n minus 1 times D. My recursive formula is a to the n equals my previous term plus D. So for finding the 15th term, a to the 15 equals my first term plus 15 minus 1 times 1/5. So that's going to be 2/5 plus 14/5, so that's 16/5. Number 15, find the 12th term. Okay, remember, we're going to do 50 equals the first term they times n, which is 20 minus 10 times my D. So 50 equals 100 plus 10D. Negative 50 equals 10D. D is going to be negative 5. So now we find A1. So 100 equals A1 plus 10 minus 1 times negative 5. So my first term would be 145. So now that I know that, we can write our explicit term. So our explicit equation, so a to the n equals my first term, which is 145, plus n minus 1 times d. When I solve this for my 12th term, like it asks, a12 equals 145 plus 12 minus 1 times negative 5. So that becomes 145 minus 55, which is 90. All right, so my 46 equals the term they give me plus 8 minus 4 times d. So 46 equals negative 2 plus 4d. 48 equals 4d. D is going to be 12. So now I'm going to find my a1. So negative 2 equals my first term plus 4 minus 1 times 12. So negative 2 equals my first term plus 3 times 12, which is 36. So we're going to minus 36. So negative 38 is my first term. So my equation would be a to the n equals negative 38 plus n minus 1 times 12. So I'm going to use that to find my 12th term. So a12 equals negative 38 plus 12 minus 1 times 12. So my 12th term is 94. Find the indicated sum. So my formula is sum n times the first term plus the last term over 2. So my first term here, we have 18 for number of terms, so let's find my last term. So let's write my explicit formula. Plus n minus 1 times negative 0.3. So for my 18th term, 3.2 plus 18 minus 1 times negative 0.3. So that's negative 1.9. So now that I have that, so the sum of 18 equals 18 terms. My first term is 3.2 minus my last term because it's negative over 2. So that gives me 11.7. Next one, a to the n equals my first term plus n minus 1 times d, which is positive 2. So to find the 15th term, negative 18 plus 15 minus 1 times 2. So my 15th term is 10. So to find the sum of 15 is 15 times my first term, negative 18, plus my last term over 2. So this would be negative 60. My next thing is, here we go. So my first term is 88 minus 3 times 1, which is 85. My 20th term is 88 minus 3 times 20, which is 18. So I'm ready to go. So the sum of the 20 terms is 20 times my first term plus my last term over 2. The answer here is 1030. So my first term is 14 minus 1/2 times 1, which is 13.5. My 14th term is 14 minus 1/2 of 14, which is 7. So my sum of 14 is 14 times my first term, which is 13.5, plus 7 over 2, 143.5.